Hi everyone. In this tutorial, I'm going to quickly show you how to use the Ladybug plugin to do solar analysis on your aggregations. So the first thing you want to do is we want to go to Food for Rhino and download the Ladybug plugin. Alternatively, I have also included the Ladybug plugin in the software folder, so it's just here. So you can also extract that as well. But we'll be using this Ladybug tools, which basically is a suite of tools that allow you to do different environmental simulations from sun, radiation, wind, airflow, etc. So once you've downloaded and installed Ladybug, we're going to be using the 008 and 08 Rhino and Grasshopper files. So I'm going to now just drag the Grasshopper file into my Grasshopper canvas. So immediately when you drag it, you'll notice that a pop-up will appear asking you for an EPW weather file. I've included a weather file inside the Grasshopper folder where you can see we're going to be using Melbourne. You can also get weather files online, so you can, if you search EPW weather files, Ladybug will point you into this, and then you can also have a look at the whole world map and see where you want the weather. But because our site at the moment is in Melbourne, we're going to be using the Melbourne weather file. So you just double click, and I might ask you again for the weather file. Yep. Okay, great. So it's a pretty simple Grasshopper script. Basically, we've got our parameters. So this basically gives us the month, day, and hour of our analysis period, as well as our angles. You don't really need to touch this bottom part. It's mainly just this part. Generally, in architecture, you analyze the summer solstice period, so 22nd of December, when the sun is at its highest in summer, and then the winter solstice, which is 21st of June, when the sun is going to be at its lowest point. So those are the kind of analysis periods that you should be looking for. So immediately we've got this component here, which sets our month, day, and hour. So we can go month, we're going to do the 12th, day is going to be the 21st, the hour, so we can specify from hour to an hour. So our day and month are going to be the same, but the hour periods are going to be different. So we're going to do 7 a.m. to, say, that's 12 p.m. So we might say till let's say 8 o'clock. Oh. So now we've got our analysis period. This basically is just defines the color for our analysis. I wouldn't recommend changing this because it gets a bit convoluted if you want to extract colors. So those are basically all our analysis. Then that all gets kind of fed into this kind of analysis engine. So you can see when I click on this path here, it's just showing us the path of the sun, and in terms of where our location is of the weather file So now all we really need to do is we need to add our geometry. So at the moment, I'm just analyzing this geometry. It can really be any geometry you want. So let's choose, say, this one. I'm going to clear this, and we'll just press pulse. And I'm going to set multiple meshes. So that's our geometry. We don't really need to worry about the north. If we had a context, which in this course you will have a context, some of you, you can add this context as a geometry. Just note it will get a bit heavy when you do that. And then everything else is basically set up for you in terms of the sun vectors, the parameters of the colors and the orientation of the sun. So all we need to do really is run the simulation, and this might take a couple of seconds. There we go. And now let's just hide this. So we can see now it's basically analyzing the aggregation. So we can see this is good because we can see basically at what point in our aggregation where the most kind of the best spots for sun, where it's getting the most sun, where it's getting the least. So obviously the tops of these components are going to get the most sun because there's no shading, and then these kind of balcony areas are getting quite a bit of sun, and then as we go deeper into the aggregation, it's getting less sun. So what we can do is we can bake this aggregation. We can just change the value or the iteration depending on what you're aggregating. We can press activate, and that's going to give you basically a mesh which shows you for where all this sun distribution is. What we can also do is we can also have a look at the legend. So it's showing us here how many hours of sunlight is basically each face on our mesh is getting. So red being 13 hours or more, and then as we go down, so you can see the blue is getting about 1.5 hours of sun per day, comparatively to the balcony areas, which are getting more than around 12 hours. So this will help to inform your designs. So, one instance might be you do this analysis and then you realize that the aggregation isn't performing quite well in terms of solar performance. So we might need to change the aggregation. And also we might need to change the situation of the aggregation on the site. Another thing you could draw from this is, you might need to change the depth of this component aggregations, stuff like that. So it's really a way to inform it. And then also another way we could use this is using this information with the orientation techniques in WASP, where we kind of can orientate the components in a particular way to this data, where we know a lot of the sun is going to be coming, say, from this particular angle. So we can see here there's a lot of kind of orange sunlight access here, so we can potentially add that kind of data into a workflow for orientating the aggregation. So that's baking the whole aggregation. Another way you might use this is, if I just hide the aggregations, if I toggle this true component on, I can search for different colors. So I can, if I just want to see where all the kind of zones in which the most sunlight's occurring. So that's basically in these areas. And then if I wanted to change this color, I could go, say, to blue. And it's going to show me now that's where all the blue is. And if this threshold basically allows you to play with the threshold of color that you're selecting. So the more you adjust the threshold, the more specific you can be about which zoning into that color that you're trying to find. So that's also a helpful analytical tool to help you understand, where is specifically is particular analytical data occurring within your aggregation. So you can see here, if I bump this threshold up, eventually I'm going to get to a point around 2.9 where I've isolated the red values. So that's important because we want to maximize kind of this performance of solar. So it's about building this data into our aggregations, which we'll cover more in the next couple of tutorials. So that's how you quickly analyze your aggregations for solar performance. This can be used then for, when you're diagramming and making then an argument for how you're judging these aggregations based on this solar performance, not just purely form and aesthetics, but some sort of underlying environmental data as well. And it's helpful when we start to build in with the context of how is the aggregation and your building responding to the context and the environment as well. So we'll be able to see stuff like the solar. So that's that for that tutorial. I'll see you in the next one.